Okay, so we're going to do a video on an application of Bayes' theorem, pretty straightforward application. Just as a quick reminder, Bayes' theorem is this really nifty thing that involves the law of total probability. Law of total probability isn't Bayes' theorem, but it's a part of Bayes' theorem. Probability. Hopefully that's all legible. So think about this. So say we have some events. Something like B1, B2, ... B, let's go with BK. And say they are disjoint, right? That means they're mutually independent, and exhaustive, right? On some space, right? In some space, they're mutually exclusive and exhaustive, right? So that means that on this space, this space is completely covered by the union of all of these B's. So what that means is that anything else that occurs in this set can be described by its relationship with these B's, right? Because they're mutually exclusive and exhaustive. So if we have some event A, then the probability of that event A is simply equal to the probability of A and B1, right? Plus the probability of A and B2, right? Plus the probability of A and BK, right? Because the sum of all of these things is the sum of all the different ways that A could occur, and we know that they're all disjoint, right? We know they're all disjoint, and we know that they're exhaustive. So now it's possible that some of these are zero, right? It's possible that A and BK never occurs, right? But that's okay. That's not going to mess with our sum. So if we sum up all of these intersections of A and B's, right, in the set, then we can get nothing else other than the probability of A, right? Because that's just the sum of all the different ways that A could happen, right? So we can write this in summation notation. Right. And if we remember our laws of conditional probability, then we can write this thing like this. Right. And I haven't changed anything there. So this is essentially the law of total probability. And Bayes' theorem takes this and just goes one step further. Bayes' theorem says, okay, I can use this thing to say, if I want to know the probability of some BI given A, well then, that's simply the probability of BI and A divided by the probability of A, right? Which is, as we've just shown, the same thing as that sum. Right? So it's kind of straightforward once you spend enough time looking at it, but it's really neat. Essentially what we're saying is that I can use information about B and a little bit of information about A to figure out what the probability of some b I is given that A. So let me show you an example.